Ugh, I don't care what anyone says. This advent of code is a grind. I mean, you got to have some serious stick to it, um, stick to itness to do all these. Um, okay, so now where are we? We are on day 16, and this is called Reindeer Maze. It's time again for the Reindeer Olympics. This year, the big event is the Reindeer Maze, where the reindeer compete for the lowest score. You and the historian arrive to search for the chief, right as the event is about to start. It wouldn't hurt to watch a little, right? The reindeer start on the start tile, marked S, facing east, and need to reach the end tile. They can move forward one tile at a time, which increases their score by 1 point, but never into a wall. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1,000 points. To figure out the best place to sit, you start by grabbing a map, your puzzle input from a nearby kiosk. For example, blah. There are many paths through this maze, but taking any of the best paths would incur a score of only 7,036. This can be achieved by taking a total of 36 steps forward and turning 90 degrees a total of 7 times. Okay. Here's the second example. In this maze, the best pass cost 11,048 points. Following one such path would look like this. Note that the path shown above includes one 90-degree turn as the very first move, rotating the reindeer from facing east to facing north, which is important. Analyze your map carefully. What is the lowest score a reindeer could possibly get? So basically, it's about getting from the start to the end with the fewest number of turns, right? Because turns are what increase your score the most. So the fewer 90-degree turns you have, the lower your score. So this is actually really similar to some other puzzles we've done this year. Basically, all we need to do is we need to do a breath first search again, right? Breath first search, where we basically just try all the options, right? So we start the maze, we try to move the reindeer up one, we try to rotate the reindeer in either direction, and then we just queue those. And then we do the same thing on every iteration. We advance one, turn, and then on each iteration, we check and see if we've reached the score. And so, or we check and see if we've reached the end. And so we should reach the end. We should hit that on the shortest path, and that score on the shortest path should be the lowest score. So how do we implement that? What if we did this really quick and dirty? I've been trying to follow some good object-oriented kind of programming, but what I'm thinking is that I'm thinking is, in the name of time, to try to get caught up, we just do this. We do this pretty quick and dirty. So I'm literally just thinking something like var result equals puzzle solver dot solve, and we pass in the input. And we just, I mean, we call it good, right? So public, or no, just static puzzle solver. And then it's just going to have one method on it. It's go public int solve. It takes a string input. Return 0 for now. Static class. Sorry, static class. Now it's happy. Let's see. And this should be static as well. Okay, so the first thing we need to do is we need to get the start position. Var start position -1 to start with. Yeah, start -1. Whoops. Yeah. Okay. We're gonna have our rows are gonna equal input dot length. Our var columns are gonna equal input 0 dot length. Then we're gonna have our start and our end. Yeah. So we say for, and then we'll say for our row less than rows, and we'll increment row. Then we'll say var, say for column less than columns. And so that's where we'll say var current equals, say var -1, var end equals -1, -1. And we'll just loop through and say current value equals input, and that's going to be row column. No, yeah, row column. Then we say if value is s, then start equals column row. If current value is end, and end equals I'm sure Ryder has a more clever way to do that. I don't think I prefer the switch in that case. But we'll leave it because Ryder wants it that way. So now we have the start and end. This is where we can start to do our queue thing. So we're going to want directions. And that's going to be a list. Yeah, it's going to be a list. A list of tuples. And they're going to be 1, 0, 0, 1. Be -1, 0, 0. So this is what we've done a bunch of times before. I'm just how do I new that up? New list of people. This might be a good time to use the target type. What was I saying? Oh, this is stuff we've done a bunch in the last 15 puzzles. I'm just not using the object-oriented approach where kind of having classes and strongly typed things to represent it. I'm just kind of trying to speed run this. So what we want to do then is we want to say var var. We basically want to iterate over basically want to say var q equals new new q, and we want, what do we want? We want the position. Yeah, we want the position. What was the limitation on the clockwise? Well, they can rotate clockwise or counterclockwise 90 degrees at a time. Yeah. Maybe I don't. Sorry, I'm getting distracted by messages. Yeah, I'm gonna have a queue. This is like what we've done before, where we have a queue, and the queue is gonna have a int and an int. I guess I could name them X and a Y, right? I can name these. These directions are gonna have an XD and XY. Let's see. However, I don't. So the queue is just first in, first out. But really, I want to base it. I always want to process the thing that has the lowest score. Right? Yeah, priority queue. So I want, if C# has something called a priority queue, so the item with the lowest priority value will be removed first. So in this case, that would be our score. So priority queue. And then we can say this is going to be an int. And then we're also going to keep track of visited, which is going to be a new hash set. And that's going to be int x, int y, like that. And then we're going to do the good old while q dot count is not 0. We're going to do some stuff. But before we get into the while loop, we actually do want to get the ball rolling, right? So we're going to say for, and we're going to say bar d. Well, d is less than directions dot length or count. We'll increase d. So this actually needs to be int x. Yeah, this actually needs to be a lot more complex. This actually needs to be x, y, xd, int x, y. No, yd. And then we can say for each direction, and directions, we will say q dot inq the start, right? Yeah, we'll say start dot why is that called item 1? Oh, because I didn't give them names. So we could say int x. And now that I've typed this so many times, now I want to make a position glass. right? Because this is just kind of dumb, typing int x and int y that many times. So now it should be start x, start y, direction.xd, direction.yd, not xy, that should be oh, and then we need to start the score at 0. Oh, and this all needs to be surrounded with a. So this is going to be n. This should be yd. So all we're doing here is we're basically just getting the ball rolling by finding the start, finding the end, and then we're just going to try every direction. Yeah, we're going to try every direction to get the ball started. And then we're going to var current equals q.dq, and then we're going to say if visited contains the current, you know it, we're going to continue. Oh, and this needs to share the same shape as this guy. Otherwise, visited dot add current. That. Now we're gonna start trying our different checks, right? So our different checks. So we want to first see if we've reached the end, right? Yeah. So if current dot x equals end dot x and current dot y equals end dot y, this is where we'd want to return the score. We don't have the score. So we are passing the score here as our priority, but we also need to pass it. We also need to pass it var initial score equals 0. We not only need to use the score for our priority, but we also need to add the score to our state here. So int score and int score. And the reason for that is so that we can say current dot score. We can return it. So we want to be able to dequeue it, and if we've reached the end, return the score back. Otherwise, what we should do is we should try to on each loop we're going to try basically 3 things. We're going to try to move in the direction we're going, like we're going to try to advance, or we're going to try to turn clockwise, right? So they can move one file at a time, or they can rotate clockwise. So if I'm looking this way, I can rotate right 90 degrees, or I can rotate left 90 degrees. So that would be, how do we do that? We say var next position, and that's going to be equal to or we could say var next x is equal to current dot x plus current dot xd var next y equals current dot y plus current dot yd, like that. So that's our next x, our next y. However, now we need to know if that's actually a good new position. Right, so we need to check it. We basically want to make sure that it's on the. We basically want to make sure that it's an empty space. Right, that's basically what I want to do. But we don't want to index off the grid. I wonder if this would make sense to have a dictionary. Right? Would it make more sense to parse the input into a dictionary and then? Okay, I'm not gonna get distracted because I feel like when you work against a dictionary that has key value or has position value, you don't really have to worry about the indexes so much. You can just try to get the value, and if you don't have it, then you just. In any event, in order for this to be a valid next position, we need to make sure that next x is greater than 0 and next x is less than rows minus 1. Right? Yeah, rows minus 1 because rows is input.length. And so it just needs to be less than that. I guess it can be greater than or equal to. And then int next y is greater than or equal to 0, and next y is less. Oh, and next y is less than columns. Or nope, those should be flipped. This should be over here, and this should be rows. If we know that, then we can safely do the following. We can safely say input next y next x does not equal the pound sign. Or it does equal an empty space. It doesn't equal. If that is true, then we want to continue to explore. So then we want to say q.inq. We give it next x, next y. We give it current xd, current x, or current yd. And then we need the new score, which is going to be current.score. Our new score equals current.score plus 1. And it's plus 1 because we're moving forward, and we're moving forward in one direction. So that's only increments our score by 1. So we say new score, new score. And this all needs to be a tuple. All right, yeah. And then we don't continue on because we want to do all of them. So now what we need to do is we need to try turning. And how are we going to turn? Well, okay. So if you think of, oh, I know. Okay, so there's 4 directions, right? And let's say we start at direction 0. The way I would turn 90 degrees this way is I'd +1 and come here. If I wanted to turn over here, then I need to go actually 3 spots. So I go 1, 2, 3, right? Now the problem with that is if I'm here, if I'm at 1, or let's say I'm facing behind me, that means I'm at direction 1, 0, 1, 2. I'm facing direction 2. Well, if I want to turn counterclockwise, I need to add 3, but that's going to put me at 5, which is too far, when I really want to be at 4. Yeah, I really want to be at 4. So the way I did the directions is not going to work. Instead of doing it with a for each, I actually need to do it with just the index. Can you guys see this? Is this large enough? For 16. Yeah, this sucks, but I'm gonna have to change this to just be direction. This is just gonna become int direction. Yeah, like this, like this. And here's the reason why. Var direction equals 0 while direction is less than directions dot length. We will increment direction. Okay, so here's the reason why we need to do that. We need to do the directions based on an index, because then we can say var current direction equals directions current dot direction, right? So we're basically using the index to get the value from this directions array, which is all the way up here at the beginning. The reason though that's important, let's see, current direction. Direction xd yd, and then this needs to just be direction, or current dot direction, like that. We'll keep going the way we're coming. What we need to do though is, why did I do that? I did that because I need to be able to calculate the new direction. So var clockwise turn. So clockwise is going to be this way. So in order to do that, I actually need to do this based on the index, and I need to say, current direction plus 1. But since this current direction is an index, and there's only index 0, 1, 2, 3. If I'm at index 3 and I try to turn clockwise, that's going to take me to index 4, which is invalid. So this is where you're going to do kind of that modulo arithmetic for whenever you need to wrap. And so what you're going to do is you're going to say directions dot length or count. But basically that's just going to prevent you from calculating an index beyond the length, or an invalid index, right? It's basically going to say 0, 1, 2, 3, right? So you can kind of do the math here. So 0 plus 1, 0 plus 1 mod 4 is 1. 2, right? And that allows me to go all the way to 3. But if I try to calculate 4, it's going to wrap back around to 0. And then if I was to do 5, it's going to wrap back around to 1, right? So it always gives me the right index that I wanted to allow me to just kind of go in a circle, to just do 90-degree turn, 90-degree turn. So that's 90 degrees clockwise. And we want to explore that. So we're basically going to take the same thing and we're going to do that. However, we're not advancing, we're just turning. So this needs to actually be current.x. This needs to be current.y. Not the current direction. This needs to be our clockwise turn. Direction after clockwise turn. Wordy, but descriptive. And then our score. We can actually say bar new score equals current dot score plus 1,000. New score after, let's say new score after move, after moving. And this will be new score after turning. We can use this here. Because again, we're just exploring every possible avenue, keeping track of the score, and using the score to determine that priority at which we explore paths. So then we can basically do the same thing, only now we want to turn counter. And so we should get to this point. If we do all that right, we should get there. If we don't get there, I think we probably want to say, well, we could just return 0. Or we could return -1. Or we could throw. I don't know what the right call is there. Yeah. Okay, so what is the lowest score of the reindeer? The lowest score. Lowest score a reindeer could get is result. I'm sure I messed up somewhere with all the X's and Y's, but I think this is gonna get us. I think this is gonna get us pretty dang close. So, want to just try it? Yeah, let's just try it. Let's see. .NET run project 16. Reindeer maze 16. As long as we don't get -1, right? Or 0, I guess. 0 is what we're scared of. Oh, this is taking a long time. Oh, I know why it's taking long. No. This is not good. I wonder if it's because visited is. Oh my gosh, I lost my screens for a second. I thought I crashed my computer. Okay, so I think the problem is that we're not doing a proper check on visited. I think visited needs to be doesn't need to factor in the score. Because if visited factors in the score, it's never going to be unique. Or at least that's the way I'm thinking. If current x equals end x, current y equals end y. Why don't we try to debug this? So we can do that pretty easily by just swapping this out and saying let's see, this can be path dot find context and then app context based directory and then input.txt. Let's see if we get the start right. Oh, whoops, I'm debugging the wrong thing. I should be debugging reindeer maze, right? I did. Oh, I got a comment. Sorry, I got to comment this stuff out too. Gotta remove that. Let's see. debug. Okay, so when we get to the queue, we should have a start and an end. Oh, interesting. They're mirrors of each other, huh? Interesting. Let me look at my input. That just seems weird. No, I guess they're literally in the opposite corners. Okay, so then let's see. We're gonna step over. We're enqueuing all the different directions. And now we should be hitting our queue. So you can see our queue currently has in it 4 items. That's basically the start position, then taking off in each of the different directions. Then we hit this. And then we're just going to keep hitting it. I'm guessing though the problem, see how my queue is just continuing to grow no matter what. It's always growing. And that's because where's my visited? Are these really all unique? Well, let's see. Let's see if I ever hit this. I do. Okay. So I am hitting unique. But I'm never getting to the end. Alright. Alright. Oh, I meant here. Yeah, it just sits and spins. And my visited count just grows and grows and grows. Okay. So, what have I done wrong then? I've done something wrong. I'm dequeuing based on priority. This is important. I'm checking if we've reached the end. I'm exploring directions. Oh. I'm not actually turning clockwise, or counterclockwise. So turning clockwise requires me to turn 1 index direction. Turning counterclockwise requires me to turn 3. So let's try. Oops, I changed the wrong one. It should be this one. Let's retry this now. See if we actually get to the end. I don't know, does this make a difference? Yeah, it seems like it's just growing and growing, never ceasing. So what am I doing wrong here? So if next is the wall, we can. Yeah, if next is not the wall, we increase by 1. The current direction. Oh, it happened again. I must be stressing my system a little bit here. Okay, so that's not it. I've run off pace. So what is wrong about what I'm doing? I think there's another case. I don't understand why I'm never reaching the end. Okay, maybe speed running this was a bad idea. Was a bad idea. It's almost 1 o'clock. Okay, so I think this is where part 1 is going to end. My first attempt at part 1, day 16. I still have yet to catch up because day 17's puzzle's already out, but yeah, I'm going to go to bed and I'm going to come back and revisit this in the morning. I'm sure whatever I'm doing wrong is going to be painfully obvious in the morning. But right now, I don't see it. Do not see it. And I wonder if I'm thinking it's because of the I'm thinking it's because the hash set. Okay, let's just see what happens. If I remove this, oops, if I remove the score from the hash set, and then I just say bar visit possible visited equals current.x, current.y, current.direction. I think that's the part that was getting me because I think the score was basically making everything unique. Let's try running again. Hey, let's go! Oh yeah, so I think that was my problem. The score was making everything unique, and so when I was basically using the hash, using the hash set wasn't doing anything because everything I put in there was unique to begin with. Okay, let's see if this is the right answer though, right? See, I spoke too soon. I almost gave up. I almost went to bed. And I had an idea. That's how it goes. It's like if you've ever done like a plank or like a side plank, like you'll be holding it and it's like the longest 60 seconds of your life. And you always know when the 60 seconds is up is the moment that you're thinking to yourself, I should just stop. And that is the moment when you're right at the end. Um, as is the case with obviously solving advent of code puzzles. So let's try to plug this in here. Okay. Well, I spoke. I I am just jinxing myself horribly. They said it was too high, huh? No, too low. But that's not the right answer. Your answer is too low. Curiously, it's the right answer for someone else. You might be logged into the wrong account or just unlucky. In any case, if you need to be using your puzzle input. If you're stuck, make sure you're okay. Well, let me just make sure I have my puzzle input. I've actually never seen it say that before. Rerun it again to be sure. Nope, that's what I got. So, turn to day 16. Let's write some tests real quick. I don't know if I'm actually going to get to solving this, but let's actually I'm just curious how far off I am. Puzzle solver. See, we can say test public async task solve. Did I call it solve? Yeah, I called it solve. Solve when called with input it should value. Then we'll have a public record, which will be our solve test case. This is going to have a string, which is going to be our input. This is going to have an int, which is our expected value. We're going to have a public static method that returns an numeral of func of solve test case. This is going to be our solve test cases. This is going to yield return one of these things new. It's this, but we also know it's this guy. This is our first test. Who knew you could do so much with 2D grids, though, right? I mean, every one of these puzzles is basically a kind of a 2D grid thing, and I mean, they just keep coming up with more and more ways to make it happen. Let's see. Method, data source, name of, solve. Oh. If a first, it's the case that caught us is this exact line here. Note that the path shown above includes one 90-degree turn as the very first move, rotating the reindeer from facing east to facing north. So, Is that what the problem is? Because technically your start direction is arbitrary, right? Hold on. Includes one as the very first move. Oh, it starts facing east. That's important. Facing east. So east to us is what? We need to actually start east. So if we're east is gonna be right. Which is this? So if direction oh we don't really need to go in every direction then, do we? We just need to like, what if I just do that? Like, what if I just do that? Run. Yeah, because now, yeah, okay. Yep. And then see var initial score, and I'm going to give this a label to var initial direction equals 0. And why that was screwing me up was I was basically queuing up turns without incrementing the score. So now if I just always queue up facing east, it'll try to turn me, and every time it tries to turn me, it will make sure and add 1,000 to the score. So now this should go up, I think, by, yeah, it went up by exactly 1,000. And that should be my answer now. Hey, looky there. Okay, what do you think? Do we go for part two? It's 1 o'clock in the morning. Do we just full send? Let's see how complicated this is. Uh, let's see. Now that you know that what the best paths look like, you can figure out the best spot to sit. Every non-wall tile, S, dot, or E, is equipped with places to sit along the edges of the tile. While determining which of these tiles would be the best spot to sit depends on a whole bunch of factors: how comfortable the seats are, how far away the bathrooms are, whether there's a pillar blocking your view, etc. The most important factor is whether the tile is on one of the best paths through the maze. Okay. If you sit elsewhere, you'd miss all the action. So, you'll need to determine which tiles are part of any best path through the maze, including the S and E tiles. In the first example, there are 45 tiles marked 0 that are part of at least one of the various best paths through the maze. In the second example, there are 64 tiles that are part of at least one of the best paths. Analyze your path, your map further. How many tiles are part of at least one of the best paths through the maze? So isn't that just removing... Oops, I didn't mean to do that. Isn't that just the best... Maybe I'm thinking about this too simply, but isn't that just my visited? The number of visited tiles? So let's see if that's right. So instead of returning at the earliest, let's just let's just continue. Is that what we should do? Just continue. So if we did this, continue, and then we said visited dot count, like that. And we don't really have to pass the part 2 because I modified the code. $40,000 spots? No, that can't be right. That seems way too many. Your answer's too high. Okay. Yeah, that's what I thought. So it's not that simple. But it isn't that complicated because we've What do I want to say now? I mean, that gets me the current score, right? This is breadth first search, so it's essentially the shortest path. But now I want to yeah, so I think bar part of path equals a new it can be this, can't it? Yeah, it can be this. And basically if we get here, then is it 460? I think it might be 460, huh? Interest too low. It's not 460 because that's 1,000. Yeah, because that's just that was just the score for the shortest path. So what we want to do is we want to continue when we reach the end. And then we want to say part of path add next x and next y. This should be a tuple. Part of path should be the start. And start x, start y. And we should also add the end. The end x and end y. And then return part of path.count. $10,125. So this was too high, and 460 was too low. Let's see. That's not the right thing. So your answer's too high. It was lower than 10,125 and 460. Okay, so that's not the right approach. Yeah, so each time I move forward, right, that's part of the path. Forward, move forward. Let's do what we did here. In the first example, there's 45. And let's see, right now, we found 104. Okay, so I'm quite a bit off there. What happens if I hit return? Oh, or what if I just break? Sorry, break. $97. So that's not, what I'm doing is not anywhere on point with what needs to be done. All right, I got part 1 done. I'm gonna call it quits on part 2, but hopefully tomorrow I can get part 2 knocked out really quick early in the day, and then have plenty of time for part 17, and I'll be back caught up. With that being said, though, thanks for sticking with me. If you're watching, I hope you're enjoying some of the stuff I'm streaming. I hope if you're doing Advent of Code, you're having fun, you're having a good time. I know it can be kind of a grind, but yeah, it's fun. We're getting better. Okay, I'm gonna go to bed. I'll see you guys tomorrow. Good day. We are back to try to see if we can't. We are back to try to see if we can't finish day 16, part 2. It's a little later in the day. Took my lunch a little later in the day, but if we can get this knocked out now, I can focus on doing day 17 this evening, and we'll be right back on track. So where I left off was part 2 of day 16, and basically what we're having to do now is we're trying to find all the tiles that are part of all the best paths, right? So in the first example, there are 45 tiles that are part of at least one of the various best paths through the maze. I think that the code I've wrote so far has pretty much got me there. I think that the problem I'm running into right now is figuring out how I need to track how do I need to track all the best paths? So just to kind of give you my idea, right? I obviously have a place. That's not what I want to look at. I obviously have a place in here where. Where's my test? Test. I'm at a point where I'm finding the best path that is the shortest, the most optimal, right? Or has the lowest score. But now I don't want to stop at the one with the lowest score. I want to keep going, and I want to find all the paths that go from start to end. All the paths that go from start to end, and then I want a unique count of the tiles that make up all those paths, right? So, I basically just want to modify this. Well, let me just not worry about part 1 for a second, and let me just modify my test case here to say that the first example should have 45, right? Yeah, this example should have 45. However, my first idea that I had was, okay, well, I can just return the count of visited, right? Because the visited how should I say this? The visited, my initial thought was the visited is going to be what I want, right? But that's not what I want. What I really want is I want to keep track of, because if I do visited dot count, it comes out way too high. And then instead of returning a score, I want to just continue. Just continue. This comes out way too high when I try to solve this. Yes, let's run all. Or not run all, I want to debug it. Yeah, debug. Debug all. So I get way more than what I need. Let's see, result is 526, and I only expect it to have, oh no, not that one. Result is 414, I only expect it to have 45. So I'm visiting a lot more places that aren't part of the map. So I think what I actually need to do is I need to have some way of keeping track of the path, right? So let me open my notepad here for a second. So here's what I'm thinking, right? I have my start, and then I have my next tile, which is for a period. And then let's say that my whole path looks like this. Dot, 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 end, end. So let's say this is one of my best paths. I need some way to keep track of these paths together. But the way that I'm traversing the paths, I kind of lose context about which path, like given the current, which path does the current belong to? Which path does the current tile belong to? I kind of lose that context. So the only way I can really think to make this work is I basically have S, which is going to be my first, and then S goes to dot, then S goes to dot, and then, not dot, dot goes to dot, right? And then dot goes to E. And if I have this kind of a structure, then I can find my way back from, given the end, I can find my way back to the parts of my path, because I know who their parent is, essentially, right? That's essentially what I'm doing. This is the parent node, and this is the child node. So it's kind of like a graph almost. But I think I can represent it just like a dictionary. Yeah, I think it can represent like a dictionary. So then once I have this dictionary of paths, which once I have this dictionary that represents nodes or steps in paths, I can loop over it and walk my way from the beginning to the end and add up all the positions. Is what I'm thinking I need to do. I don't know. Did that make any sense? What I just said? I don't know if that made any sense, but that's the only idea I currently have is I have to have some way to know what is part of a path, and the only way I can think of to know what is part of a path is this approach. So let's try to implement it. So I think I think the first thing I can do is I think this visited variable, which is currently a hash set, I think that this can become a dictionary. So if I turn this into a dictionary, that basically has one of these as the key, and then another as this. So basically, this is my mapping, right? Going from this to this. Then down here, instead of saying contains, I will say contains key, like that. And if it does contain that key, then I can continue still. Otherwise, I can say visited possible visit equals if I haven't been here, then I know we're at a start. And if we're at the start, how do we want to denote that? I think I'll just use null. So null means we're at the start. We can make this nullable. Then, instead of returning the score, I'll continue. But I need to reset the start here. Right? Right? I think that's right. Is that right? Does this make any sense what I'm saying? Let's just try what I have in mind. So, I also need to say visited, and then this. Because we need to include the start. And that is going to be equal to null. Yeah, that's going to be equal to null. So yeah, so this has no parent. Start has no parent. I guess what I'm saying is start is null. Then this is so my value is actually going to be my value is going to be my parent. Is what I'm saying. Yeah, my value is going to be my parent. Then we check if we visited, and if we have visited, then we continue. If not, possible visited is null. Yeah, I think that makes sense because now we're saying we're basically initializing. Then we need to figure out if that actually has then we'll come down here. We'll say, and we'll say, what do we say? We'll say, this will now need to be not on queue. It'll need to say visited equals next. Basically this. So this guy's parent is the current. I'm going to change the name of this because this keeps tripping me up. Current. Current. Position. That'll work. This will be equal to current position. Oh. Also visited. And I think we need to do that down here too. So now we need to say var or no visited. It's basically this same statement that only now it's these three. And then down here it's these three. That's how we know it belongs to that's how we know that this new position we queued belongs to this guy. Although I don't know if I like that the child is the key and the parent is the value, but we'll see how that feels once we start iterating. Okay, so I think this is the thing. I think this gets us where we need to go. I can't figure out what I want to do when I reach. If we reach the M position, then what? If we reach the end position, then what? Do we want to break? And we want to say, we probably need some sort of pointer. That we call like var, maybe x, we say like int x. Basically want to say this. We say final equals null. We can say if we do reach the end, final equals current. Or maybe we call this end. Oh, there's already an end. Final can work, that's fine. But current, why can't we assign current? Oh, we need to assign possible visited. It's assigned, but its value is never used. Okay, so this theoretically should get us to a point where we have a dictionary of path. So, let's see. No. Okay. Then let's see where this gets us. So I'm hoping at the end of this, debug. This is a dictionary, but it only has one in it. That can't be right. That's not right. They should have a lot more than that. Um, what did I screw up here? Oh, okay. I don't need to do this. This I don't need to do. Okay, so put that breakpoint back, debug it again. Okay, visited 4. It got to the end really quick. That doesn't make sense. Debug. So what the hell? Why is it? Why is it jumping? This, we're enqueuing all these, what I would expect. Now we should go back to the top. We should dequeue. Well, yeah, now it's always going to hit. It's literally just going to dequeue all these and not explore any further. So this shouldn't be. Okay. So do I need to add another check? Or should I be not checking up top? Yeah, I guess because up here I don't really care if I visit them. I don't need to do that. Guess I don't. What happens if I don't do that check there? Oh, 370, huh? Ooh, that's a lot. Yeah. You guys home? You have a good day at school? Okay. The problem is that I have multiple paths, right? And this algorithm that I've written is just finding the shortest path. Yeah, it's just finding the shortest path. So what I want to do is I want to process everything, and every time I find the end, right? I'm all starting at the same place, and whenever I reach an end, that should be a complete path. So theoretically, ideally, I would end up with a structure, right? That's like, okay, you're at the start position, and then you'd have another one that's like at the start position, dot, 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 and then maybe this one just is like this. Um, and these could all be in the same. These could all be in the same structure. Uh, so then how would I delineate? um, Because some aren't going to actually be part of the path. Now I want to back all this out because now I don't feel like it makes sense what I'm trying to do. I feel like that was a false start. So let's back this out. Just walk all this back to where we were. Boys, focus on what you're supposed to be doing. I mean, this is the part where we actually move, right? This is the part where we actually change positions. And I don't really care so much about the direction. I just care that I've been to that tile. But that tile needs to connect to an actual end path. So, oh, excuse me. Excuse me. So let's just do something simple to start with. Let's call it bar half graph. It's called a new dictionary.
I'm doing some, okay?
And instead of worrying about the direction, how about we just worry about position to position? And let's actually call this char value. And then what we'll say is we'll say if this is possible, then we'll say dictionary path graph dot add, and so the key should be the current, and this should be the next. So this is the next, which is the child, and then we don't care about the direction. What we care about is the value at that position. So we have our input. We say next y, next x. And then this is going to be current x, current y. And then we'll do the same thing for the input. We'll get the current thing there and the current thing there. I've been on this for 37 minutes and I have not really made any progress. Okay, so everything else is going to stay the same. And let's see what happens. Debug this. I just want to see what this graph looks like. An item with the same key has already been added. 113S. Well, let me think about that. 113S is added twice, which is the end. What happens if I do multiple? What happens if I do different directions? Does the direction make it unique? So if I add another int, it is direction. Down here, if I say current direction, well, that's not going to make a damn bit of difference because it's going to make, because these are the same direction. That's not going to change this. Let me just see. Let's see what it looks like when we get to this point. Oh, this is not the end. We're talking about the start. We're talking about the start. We've added the start node multiple times. So what if we have a list of paths? Does that make sense? Paths, and then we say this is called a list of dictionary that, and then var path equals this. And then once we get here, no, that doesn't solve anything because we're still Okay, so that's why I should flip them, huh? Yeah, let's try doing the child as the key, parent as the value. And now let's see what this looks like. Multiple keys. Okay, maybe dictionary is not the right structure here. Maybe the right structure is a list. Maybe the right structure is a list of these. List of that. And maybe it's specifically a list of that. This can be called parent. This can be called child. And so then this can be add. There's way too many parentheses going on here. I really need to clean this up. But now this shouldn't throw because of uniqueness. Visited is 414. But now these should all contain not visited, paths. So now path should all contain a start and a next. And so we should be able to should be multiple starts in here. How many are there? 218 nodes, I guess you could call them. Okay, so we stop this. And then down here, once we've been through them all, we should be able to say for unique positions equals new hash set of int x and int y. Then we for each can say var start positions equals paths dot where p, we can say p dot parent dot value is s. Then we can say unique positions add start position dot parent x and start position dot parent dot y. But this is where we're going to start. Oh man, there's got to be a better way to do this, but this is like the Steven dumb way to get it done. So for each position, we'll add it. Then we're going to say and then for each start, we're going to proceed to its end. So then we'd say our next position equals start position dot child, and then we'll say while next position dot value is not e. We're gonna keep iterating. Say unique positions add next position dot maybe this should be a do while loop. Do we say next position dot x and next position dot x, next position dot y. Hey guys, leave each other be. And we'd reset next. Next position equals unique positions dot where p dot parent paths dot where so there could be duplicates though, couldn't there? Be duplicates. Position equals start position dot point. X Y, and then I guess the next position is just going to be first where well, let's see if it throws. So where P, and then it'll be where P dot parent equals current position dot equals current position. E cannot convert source type to target. Where parent is current, position is going to be parent. No, it's going to be P dot child. No, the next position's parent needs to be the current positions, right? But I think that's just going to produce the start position. Yeah, that's not helpful because that's just going to get us maybe it needs to be our next position start position dot child. Their parent is this guy, and we get the child. Because these are essentially duplicated values. Parent and a child. The corresponding parent is equivalent to the child. Parent's equivalent to the child. So I just need to make sure that here, say unique positions, add start position. Well, let's see what happens here. This may blow up on me. Yeah. Oh, God. Okay. So let's just do the first. I honestly don't know if I'm going in the right direction with this at all. Yeah, because there's going to be some of these that don't actually reach the end. Man, I'm really twisted up on this one. But that's not going to work. That's not gonna work. Excuse me. Okay. It's it's dash. Let's see. Let's just reset ourselves here. So we've got our hash set of visited, which I think is good. But we do need a dictionary because we need to keep track of who the parent of each of the visited is. I mean, I know I can't get away from that. I know I have to have some sort of parents, and I know it needs to be a dictionary that basically mimics this same structure. I know I need to check if I've been there. I know if I reach the end, I want to continue. I don't want to return the score here. Visited contains. Okay. If visited contains, I know I want to continue. And then I know after I on cue something, I need to add it. I need to keep track of that parent. So I need to say if parents dot contains if it contains the, in this case, next x, next y, and current direction, it contains the key, or I guess if it doesn't contain the key, is false. Then I want to add it. So I'm going to say parents dot add guy. The value is going to be current x. And I want to do that every time I on cue something. Now I want to check for this key. If it's not there, I want to add it. I want to repeat that same logic here. But instead of clockwise, go counter. So that should protect me against duplicate keys, I think. And then that should basically give me all the visited. Then down below, I basically want to say for each var visit, or for each tile and visited, var unique path tiles equals new hash set of int x and int y. I want to say, what do I want to say? If tile dot x equals end dot x and tile dot y equals end dot y, I want to do something. So if these don't equal, we can just continue. Otherwise, we're going to try to build our path. We're going to try to recreate the path. So we can say var current equals tile. Then we can say while parents contains current, then unique tile paths add tile. Yeah, add tile. But actually we just need to add tile dot x tile dot y. Otherwise, we can then say current moves to parents current, right? Parents current. And we can say unique tile path dot count. Let's see. Is this? I'm kind of throwing stuff against the wall. I know I need to walk the path backwards. Right now, I'm just I'm ping ponging back and forth between two spots, which isn't at all helpful. Mm. What am I doing wrong? I'm doing something wrong, and I'm not quite sure what it is. So this is the end, and here's my tile. We continue. At what point do we get here? We're at 113. He is 111. I don't understand how it's possible to go to 113 to 113 again and again and again. That shouldn't be possible unless we've made a mistake here. These should never be the same values. These should never be the same values. I feel like I'm making no progress at all. Ugh. Ugh. I guess what I can do is I could also set a conditional where uh, where possible visited equals 1, 1, 3. Oh, Getting frustrated. Getting frustrated. Current equals end. Then we just continue. Otherwise, I feel like I need a smaller puzzle input or something to wrap my head around this. I mean, this really just doesn't make any sense, does it? Right? So the tile is equal to the current. If the current's in the parents, then we're reassigning, which is just going to be the same thing. This is an endless loop. I think what we actually want to do so since we're starting at the end, we want to work our way back upward. So the parent should be our value, and the child should be so end is 13.1. What we get stuck on here does this ever change? Are we I mean, I guess it does change. But we never get here. Because now we're bouncing back and forth between 113 and 0, 113 and 0. Okay, so I think this logic's wrong. Because 113 is what? 113 is the end? No, 113 is the start. So I think we actually need to say while parent I think we need to say do while oh no, we need to so maybe what we say is while parent dot contains key and current dot x does not equal start dot x and current dot y does not equal if current x. Hello. Thank you. Now let's see if we ever get down here. '24. But we were expecting something different than that. I think we were expecting 45, weren't we? It'd be kind of interesting to see. This is X and this is Y. So 1, 1, 1. That's not on the path. 2, 1. None of these are on the path. 3, 1. 12, 1. That's on the path. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many times do we hit an end tile? We found an end. 2, 3, 4, 5, 6, 7, 8, 9. Oh no, that's. I want to check how many times we hit this. Sorry. 1, 2. Bar in tiles equals visited dot where v dot x equals n dot x and v dot and we could say to list. There's 2. Is there only 2 paths? Yeah, I'm not sure I understand this. This one may best me, because I don't get it. Shoot, what did I just do?
I did. I said thank you.
Yeah, so
It was super cute.
only 2?
This gift.
6 plus 28 equals what? 64. So 7 turns and 36 steps, 10 turns and 28 steps. Our steps equals new list of X. Why is this 219? Why is it 219 but the score is always correct? Turn this into a hash set. And 4. Excuse me. think I'm going to take a break from this one because I'm stumped. I don't know what to do. Yeah, I don't know. I'm going to take a break. I'm going to think on this and try to come back to it a little later because I'm stumped. So, I'll see you. I'll see you when I. All right, we're back and we're going to try this again. I'm honestly, to be just completely honest, I'm incredibly frustrated with this problem.
This is a reminder. Give Cal and Kyler their medicine.
Incredibly frustrated. Okay. What do I want to do here? I'm gonna refactor a bunch of this to make this more manageable. So the first thing I'm gonna do is I'm gonna create a directions class, which I already have one. Actually, I'm gonna have a position. Have a position class. I'm also gonna have a direction class. This can be pared down. Need all this. Don't need all these. Fine. Okay, so this should allow me to simplify some of this. So this can be var. This can be actually this can just be now list of direction. This is going to be direction dot right, direction dot down, dot down. These all need to be public. Direction dot left and direction dot right. Let's see. This is just going to be a position or new position. Let's see. New position. Let's see. And then down here, what is this? It's a position and a direction. Uh, we say call a record and call it what do we want to call this? a tile, maybe? No. Path? No. Path has public. Let's see. We use the record syntax and just say a path has a position, it has a direction, and it has a score. And then we can over here, we can replace this with a path. Then this will just be a new direction. We actually want this to be int for direction index, I think is what we want to call this. So then we can say start x new. This is going to be xy. So that's our position, initial direction, initial score, initial score. Then we could call it path current what do we want to call it? We could say path yeah, how do we want to do this? So possible visited, it needs to be sans the score. So path dot public current file. Maybe we say record tile has a position and a int has a position, has an int direction index, which means that this will then return public tile, current tile, new position and direction index. Position. It would help if I could spell. Let's see. Then we say here, we can say path dot current dot, we could say to call this path current tile. This is actually going to be a tile. Let's see, path dot F2 tile. Call this F2 visited tiles. That we can say if visit tile contains current tile, if current tile position dot x equals in dot x, or current tile dot position dot y equals in dot y. Actually, we can actually say if current tile position equals end, because now end is a position. So F2 end position to start position. Let's see. Let's keep going. Let's keep going. Next is going to be current direction path. No, this should be current tile. Yes. Yes. Goodness gracious. This one really kind of, like, I was actually while I was away, I was actually kind of like getting worked up, kind of like angry at how stumped I am at solving this problem. Um, and I just, yeah, I'm just frustrated by it. Then this is going to be current tile, current position dot x. Actually, we can get the next position by just saying bar next position equals current tile position dot get next position, and we can pass it the current direction like that. And then here, instead of doing all this, we can say next position x, position x, like that. Let's see, next position x, and then all of these are going to be next position y. And we should probably put this in a method. Um, Then we're going to on queue a new path. Which is going to be bar next path equals new path, and that's going to be equal to the next position, the current direction, and the new score. But this actually needs to be current. This actually needs to be current tile direction index, because we're doing the indexes. And then this can all be replaced. Let's see. And then we need to do a similar thing down here where we say new path be the current direction. No, current position. Current position. Right? Position. Oh no, current tile. Sorry. Current tile dot position. This new direction. This should be direction after a clockwise turn. Yep, and then this should be that. And this should be tile dot direction index +1. Would be same kind of thing here. And this should be a similar thing. Okay, so we achieved a little bit of cleaner code, a little bit easier to maintain and understand. This hopefully will still return us our we wrote something. I think this should be up. Now, so we can say var I gotta go do the put the kids to bed, so I'll be right back. So then when I get here, I could do this, and I could say best path equals path like that, and I think it would still work. Nope, it won't. There we go. Yeah, it still worked. Okay. So now we want to do something different. Um, yeah, so now what we want to do, we want to not break here. We basically want to extend this. Let me say this has a list tiles. Um, and this needs to essentially become tile, or we call it tile current tile. Yeah, and there's no need for that guy. And we kind of start a new thing here where we say our start tile is this. Our start tile to our path. Start tile. Or just an empty. Or could we do this? Tiles dot last. Um, which means current tile is going to be the last tile. If the visited tiles contain current tile. Now what we want to say is we want to say our next tile equals new tile. This. Then we are going to say tiles tiles next tile. Do a similar thing here. Next. Next, I'm getting hung up on names, but names are important. Next tile after. And then this is going to be bar next tile after. It's me to use the width. It's going to be tiles next tile after clockwise turn. And next file after counter, which is going to be this. It's going to be this. Continue, we're going to break, and this should all still work. Okay. Now, we don't want to break here. So what we want to do is we want to say if the score I got distracted. We want to say is best score. Yeah. So what we'll do is we'll have a best score. Our best score equals, we just want to start this off super high. And then if we've reached this position, the best score is going to equal path.score. But we need a check here that basically says, well, wait, if current, not current, if path.score is greater than best score, this is our new break condition. Why is this always false? Down here, what we're going to return is we're going to return best score. Why is it? It's complaining that it's always going to be false. Why is it always going to be false? It's not always going to be false. I think if I was to run this right now, it would pass. It's not always false. Then we need another check to say so if we debug this, we should have a path. We should have a best path with a bunch of with a bunch of tiles. Yeah, 44. This would actually be path with tiles equals to path dot tiles, and then a new tile that is that's the end. Um, the end tile. It's going to be end position debug this again. Gives us a 45, which I think is what we wanted. I think that, so, right, 45, and then the second should be 64. One. Okay, so we don't actually want to do that because the end's already there. I think what we want to do here is not necessarily. Let's see. Let's try this. So we'll say var best seats equals new um, seats equals new hash set of position. Then we say we get here, we say best seats dot union with path dot tiles dot select t position. Do I even need to do that? I don't even know if I need to do that. Yeah, so let's see what this best seats is 47 or 37. But the best path only has one tile. Oh, this should be continue. Stop. Okay. Debug. So why does this only have one tile? Oh, it's because we're not resetting it. Stop. So how do we get it says 44 tiles, but best seats only has 37. I'm guessing that's because there's duplicates in here. can feel it. I'm so close. I can just feel it. Why am I doing that? I don't need to do that. I can just pass that. This can be start position. Best seats could be tied with what? Um, um, mm, for for each. Gonna say input. Basically, just I'm trying to visualize what is the difference between So then we say characters equals row dot to character array, then characters position dot x equals that, then row or input y. No, we know this should be fine. So debug x is outside the bounds of the array. Excuse me. Well, how is that possible? Position x. Well, that's better. Will that work better? So we are missing some other. It's like we're not exploring. Is it because I'm not exploring all the directions? Is that what? Is that my problem? Should I be looping over all of them? I don't know why. What happens if I don't do that? Yeah. Can I what? Yeah, I did. I already did when it was time for bed. Oh, I'm sorry, buddy, but I did. It's time for bed. God, this is so frustrating. I don't understand what I'm doing wrong. I feel like I want to rage. I think this gets us all and then some. We shouldn't have 1, 2, 3, 4, 5, 6, 7, 8. But it's saying that we should have explored these. And that we should have explored over here. Should I be doing this check after these checks? Oops, sorry. That doesn't seem to have made a difference. I'm still at 36. And I'm still at 44 tiles. Should I be keeping track of? Visited contains current tile. I'm like, at this point, I'm kind of reaching because I just don't know exactly where I've gone wrong. Oh, is that where I gone wrong? 45? Okay, let's try the other one. Debug. Now this is stuck in an infinite loop. There's something about my tiles. Does my visited need to keep track of the tile score? So what if I turned this into a dictionary? It says dictionary tile int. And then I say visited tiles equals current tile along with what would I put here? Along with the current score, along with the current yeah. So then we could say I guess we would say current tile and path dot form. Yeah, so current tile equals current score, and then what we could say if get value or default, which would be int max value. Not implicitly convert from int. Oh, then we'd say if this is less than the current, or continue. What? So maybe that's not helpful. I just don't understand why I'm not coming up with the same. I'm getting the answer to the first part right, which is fantastic. And I'm close, I think, on having. I just don't have all the same positions. I don't know why. Is there more that I should be queuing? What happens if I. I break? Current score is 8011. A current path has 20 tiles in it. Let's see. Does my queue have. My queue still has 147 items in it. What if I did a check here, and what if I said if best score or if current score is less than or equal to and best or current score is less than or equal to best score. Oh shit. Oh, I just spilled coffee. Hold on one second. I'm coming apart here at the seams. My leg's falling asleep. I'm spilling coffee. Oh, no, my leg. Ah! Ah. Best seats is still 37. I just cannot figure out how to get to the 45, which makes me think I'm not exploring all the different. Makes me think there's a problem with my visited positions. It makes me think. Don't know if that's a good sign or a bad sign. Hello? Yeah. Okay. I don't know. I'm having why is this thing is freaking out? Uh What's interesting is that this, if I don't do this check, I can get to where I want to go. I thought I could. I got to 45 at one point. Was that when I was doing this? I've seen that got me to 45. Now, when I do the other input though, I seem to be stuck. Do I ever reach this position? My queue is ginormous, 815. Okay, so I don't know what I'm doing wrong, but it is curious. Let's see. If I get to this test, I look at the new input after we modified it. So it's very clear that what's preventing me from going over here is the fact that there is a tile here. So maybe this tile needs to take into account the score. Stop. Yeah, let's stop this. So what if we make this tile or int, and we say if it contains current score, This one does not run to completion. Which I don't understand. I don't understand how it does get to an end. My maybe my input's wrong. Let's just double check my test. Maybe my tests are wrong. I think so. No, that's right. I don't understand how it never. Why does it just end up in an endless loop? Maybe I only need to check here. God, I hate that I'm not. I hate that I don't have any type of real handle on the problem. But I'm kind of if I am gonna solve this on my own, this is all I know what to do is to just kind of experiment. Otherwise, um, let's see, debug. Reset. Because basically that check does the same thing. Um, well, that's down here. Um, we go through again. Next position. Next position is going to be 116Y, which is not that. So we turn. I think my coffee spill may have really done a number on my USB stuff. So I've got. Oh my god, that's gonna annoy me. My bad. Oh my goodness. I'm having all kinds of technical difficulties. Yeah, sorry. I thought when I disconnect that USB, it disconnects me from the internet altogether. My bad. Where was I? I was trying to figure out why this thing never exits. It would kind of be interesting. I think a better way to visualize this would be to basically basically do this same thing. But do it here. And say for path dot public in place tile or place input. And then bar input copy. This is going to be tiles dot select p. And up here, say bar current input. Path dot place. Give it the input. I'm just trying to see on each turn of the loop, kind of what is being explored. That's what I'm trying to figure out. Current input. So we're down there. We're working our way up. We're working our way up. We're working our way up. And then we should turn pretty soon. Holy shit, is there something wrong with the thing I copy and pasted? Oh my god, I'll be so pissed if that's the case. But how was I getting the right no, that's the right input. Where's the input? Yeah, it should have turned right here, I thought. But it kept going, it just kept going straight. Why didn't it try to turn right? And now we're starting over. So direction 2, going to his left. If I start going east, which is right, then I go 0, 1, 2. So if I'm facing left and I turn counterclockwise, if I'm facing left and I turn counterclockwise, I should go down. Right. Let's see, right. If I'm facing right and I want to turn counterclockwise, my directions in the wrong order? Is that what I've been fucking up? Yes, let's see if that's the issue. So I should be at the start position right here, 115. Now, direction index 1 is down. Yeah, so if I'm facing right, if I'm facing this direction and I turn clockwise, my next direction is going to be down. If I turn counterclockwise, it's going to be up. So counterclockwise, the 1 is down. 1 is down. And then, let's see. Direction after clockwise turn, which is 3, is 0, 1, 2, 3, is up. Yeah. Okay. So I'm turning in the right direction. But but something happens where I get here. I never touch it. But yet... So, let me see how that changes when I put this in. Because this runs to completion. Which means it must take the right turn. Yeah, see, this is doing what I thought. So I've got one that does what I thought my algorithm was supposed to do. I've got one that doesn't, right? Because what this is essentially doing is exploring all the paths. Like you can see it changing. Yeah, see, there's the. This clearly exploring. But I think the reason for that is because it takes a long time to reach that first score. Um, yeah, that first score is like 10,000 or something. Then it quickly. But it only has 49 seats. What if instead of breaking here, we just continue? What happens there? Can I snooze that? Stop notifying me about that. Uh, Still gonna make that sound though every time it.
Test.
This is not. I'm. This is not productive, is it? I've been sitting and staring at this for hours now. losing hope. So why does this in one case allow us to explore all the positions, but in the other case it doesn't? We search right. Right off the bat, we're already doing something funky. Okay, so we are going right here. Do we ever go all the way over? Yeah, okay. We are going all the way over. But we only hit 736 one time, and we should hit it multiple times. We should hit it multiple times. And something about the visited tiles causes us to avoid hitting it. Um, we've tried adding the score. So right now the tile is a direction and a position. A position and a direction index. So you would think what makes them unique? Um, so we should hit this one time. Seven 36. Now we should come back down here. Are you saying that the very next time we loop? That's basically what you're telling me is that the queue has 146 more items in it. But it doesn't get to process those. They're all greater than 836. Jesus Christ, man. I'm down and out bad. Just hard. I don't know what to do. Wonder if I'm just halfway curious. Seats dot count. Just curious. Dot net object 16 input. Yeah. That's not the right answer. If you're stuck, make sure you're using the full data input. There are also general tips, or you can ask hints. Because you have guessed incorrectly 4 times, please wait 5 minutes before trying again. Well, fig. What happens if I remove that? Does this run endlessly like the other example does? definitely need this in there. But I need to figure out why. Need to figure out why bar current position. Need to figure out why. This would be done up here. I don't know what I'm doing. I don't know if it's worth me continuing to sit here and stumble through this, or if I should just call, if I should just tap. Maybe I should just tap. I mean, the long and short of my problem is that long and short of my problem is that I'm not um, I'm just finding the shortest path. Um, and if I've already been to a tile in the shortest path, I'm not revisiting it because I've already visited it. This sucks, man. This really, really sucks. Oof. Interesting. Oops. Hey, we got to 45. Okay. Well, that's because we're never. That's probably because we're never adding to visited tile. Okay. So we still got to 45. Now, what happens to this guy? He stops running forever. No. Was that it? No way. I just needed to check if I had visited before I queued him instead of doing it after I queued him. I think that just gave us. I think that just did it. Holy shit, the 64, 45. Okay, so let's add 2 tests. Um, so we'll give it another boolean that says bool is part 2, like that. So this will be false. This will be. Oh my god, I'm so excited. If that was what the whole thing was, and then I can say test case dot part. Let's see. Now let's add these same 2 test cases. But now we're going to say true. True. This one's going to be 45, and this is going to be 64. Okay. Okay. Let's give it the input. Uh-oh. So how long do we let this run before we think there's a problem? I thought I had it. I thought I had it. No. Damn. Let's see. Stop this. Run the unit test again. What if I add another check up here? That's that breaks it. We don't want to do that check here. Use dot count. So you can see the size of the queue is just growing. I mean, it does dip sometimes, but it's just on an upward trajectory, pretty much. If, well, let's try this, contains tile, continue. Let's try that on our input. Was that what we got last time? I think what we got last time was 460. I don't like that. It doesn't even tell us if you're stuck, make sure you're using the full. I don't like that. It doesn't even tell us like our. Doesn't even tell us if we're bad or good or not. Yeah, I think I'm done sitting here trying to figure this out because I can't figure it out, and I should just probably admit defeat and move on to day 17. But I hate that I'm this close. I hate that I have my examples working. Um, and yet I can't get it to work on my can't get it to work on my yeah, this really sucks, man. Really, really sucks. Makes me want to see uh, private async task of string. Yep. Input learn await file dot read all lines. Why is it making me do that? It seems weird that it's making me. I've not had an issue with that before. Using system.io. That's super weird, huh? But it resolves file just fine. It can't resolve path. What about over here? Program. Yes. Path dot. Can't resolve it. Oh shit! It's because of this. F2 maze. Fine. That's. I was. Oh, I'm on the struggle bus. So part one ran. It did take a while though. It's taking much longer than it did the first time I ran it. Took 10 seconds. So maybe part two is just super not performant. I mean, how big is my input? I mean, it's pretty ginormous. So 41. Zeros, is it? It's a big input, so maybe if I let it run. Oh, it finished. But what did I? Shit, I don't know what what did I change? I don't think I changed anything. Did I? I don't think I changed anything, but it finished. Well, shit, what did I just do? So it took takes about 10 seconds to run. Oh, you know what? I was calling this I was calling this debug method, or this troubleshooting method, like that. And I'll bet this was slowing it down a huge amount because I'm looping over the input on every single time I DQ something. I'll bet that's what it was. Yeah, I think that's what it was. Oh my gosh, that's so embarrassing. So I had the right answer, but I screwed myself by trying to have this guy in there. Yeah, so if I just remove this, it's slow, but it runs. Yep. Okay, so let's see let's see if 575 is the right answer. Yeah, dude. Yes. So the whole problem that I was stuck on for more than an hour, more than an hour, was basically I was I was basically in queuing everything blindly, and then at the top I was doing a check to say if this thing that I in queue has already been finished or has already been visited, then continue, which was preventing me from further exploring paths. So what I needed to do was I needed to actually only check only in queue if it's not already in the visited tiles. Mm, which we can probably make a private method called uh, private void I was going to say I could probably put this logic in there in some method, but I think it's fine where it's at. Oh man, that was tough. Why was that so difficult? Um, okay, let's pull this stuff into separate files. What's this called? Reindeer maze. I'm so glad I didn't give up. Fantastic. Then we need to do a readme. But I also need to get checked out lane. I'm on the wrong branch. Get Branch, delete. Code, readme. Open on the wrong screen. 17 or 16. Bruh. Part 2 can go. Huh. Can go fuck. Can fuck off. That was by far the least enjoyable puzzle I've done as part of Advent of Code. I mean, part 1 was like, got it. It was the part 2 that was tricky. And the whole key to part 2, is, I mean, obviously it was checking if I visited before I enqueue, but the other part that was the part that really was the unlock for me was this part. No, where is it? It's called, what did I call that? Maze path. Doing this. This was the unlock for me. Because now, whenever I get to a point where I've reached the end, along that path, I've collected all the tiles that are a part of that path. And now every time I get to this point, right? Every time I get to this point, I can take the tiles that I've collected along that path and add them to the best seats hash set. And so if there are duplicates on the path, they'll just get intersected and will only have unique at the end of the day. So this is getting hit multiple times in my solution, but we're only getting the unique tiles that are a part of that best path. So yeah, that's pretty snazzy. That was the unlock. Did I do this? Oh, I wanted to also say, but so glad I did not give up. Okay. Solved day 16, part 2. This is going to be the longest video of Advent of Code for me so far. This is well over. Well, I think the longest video is actually 6 hours, so maybe this won't be as long. But I think I'm going to call it there. I'd really like to start on day 17, but it's 11 o'clock at night, so I don't think that's going to happen today. Maybe it will. I don't know. Maybe you'll see me get back on at midnight and have another go at it. But I need to get up and move around for a little while, because for a little while there, I was ready to punch some people in the face. Yeah. $32. Okay. I will I'll see you guys next time. Hopefully there's better days ahead. I don't know. I have not done puzzles this far, so if every day becomes like this, I might not make it very many more days, but we will see. Anywho, hope you guys are having a good week. I will talk to you. I'll talk to you later.